We all know that aging is inevitable in the real world. Not unless you're like Adeline in the movie The Age of Adeline, who, after being struck by lightning, seemed to stop aging. Although what happened to her has a scientific explanation, we cannot help what it would be like to stop aging. Imagine how powerful humans could be if we could stop or even slow aging and be forever young. For astronauts, this is possible by spending time in outer space. In this episode, Science Curiosities explains why astronauts age slower in space. So hold your breath as the countdown for the launch of a spacecraft starts. Subscribe to Science Times to stay caught up about knowing what happens out there. It all started with Einstein's theory of relativity. Time is relative, he adds. According to the brilliant physicist, how time moves differs for each person and heavily depends on our position and space in space-time and on land. In short, time moves differently for each of us because of time dilation. Time dilation happens when someone moves very fast. He tends to experience time slower than others. This occurs when astronauts are launched into space, called the relative velocity time dilation. This phenomenon was tested on NASA's first twin astronauts, Scott and Mark Kelly. In 2015, Scott, the space twin, left the Earth to spend a year in the International Space Station for NASA's first historical one-year mission, while his twin Mark, the Earth twin, stayed on land. They were chosen for the experiment as they have similar genetics and environment, making it easier to compare the difference between aging in space and on land, even by a few seconds. Because the ISS is not traveling near the speed of light, as Scott navigates outer space, he only slowed down his aging by a minuscule amount. Susan Bailey, a professor of radiation cancer biology and oncology at Colorado State University, who also worked during NASA's one-year mission with the Kelly twins, stated that isolation, microgravity, high carbon dioxide levels, and cosmic rays accelerated telomere shortening. Telomeres are a region of repetitive DNA sequence at the end of a chromosome. At each end, there's what we call the telomerase. This enzyme keeps telomeres from wearing down immediately, as cells divide continuously for our body to grow and body tissue to renew. The enzyme cannot keep the telomeres from wearing down forever. There will come a time when the said region will start becoming shorter as we age. With 10 research teams monitoring the changes in Scott's body and more than 300 biological samples from him and his twin, they found that Scott's telomeres lengthened during the spaceflight, much different from their hypothesis that it would shorten rapidly. This is because scientists believe that our health deteriorates much faster in space, signaling that we are aging much faster too. It was then concluded that astronauts age slower in space, supporting Einstein's relativity theory. Scott returned to Earth in 2016, 0.01 seconds younger than his twin. It still needed to be clarified why Scott's telomeres lengthened, but Einstein's theory has something to do with it. However, after landing on Earth, Scott's telomeres shortened rapidly, even shorter than before flying to outer space. It stabilized after the following months, with the average length of his pre-flight telomeres. Shortened telomeres are linked to cardiovascular diseases, while lengthened telomeres are often linked with cancer. Either way, Scott has to face one of these, and it was the first one, as his heart shrunk while he was on ISS. Although many changes in Scott's body returned to normal, many things stayed as they were when he was on spaceflight. This proves that the health effects of staying in space are quite significant. Becoming an astronaut is all about thinking long-term. An astronaut undergoes a hard training that will prepare them for what's to come once they find themselves floating in the middle of a vast blackness with only their breathing they can hear. Indeed, it takes courage to be one. Scott Kelly is the living proof. If you liked this video, give it a thumbs up and feel free to comment on the science videos you want to see next. Stay curious and subscribe to Science Times.